Hello everyone, this is Amritpal Singh. Welcome to the next video. Guys, in this video, we're going to talk about the next step of this CNN, which is called fully connected layer. In my previous video, we have talked about the flattening step. Let's get started. So this video is in continuation of the previous video. In case you haven't watched the previous video, I'll be putting up the link of my flattening video in the description box of this video. So let's get started. So what this step is all about? Well, in this step, we are adding a whole artificial neural network to our convolutional neural network. So to all the things that we have done so far, which is convolution, pooling, flattening, we are adding a whole new ANN on back of that. So here we got input layer, we got a fully connected layer, we got an output layer. And by the way, the fully connected layer, in the ANN, we used to call them hidden layer. And here we are calling them fully connected layer because they are hidden layers, but at the same time, they are more specific type of hidden layer that because they are fully connected layer, right? Why it is called fully connected? Because this layer is fully connected to each of the previous neurons, right? In the same way, this red one is fully connected to this green ones, right? That's why it's called fully connected layer. So here we got a better looking ANN where we have 5 attributes on the inputs. Then in the first hidden layer we got 6 neurons. In the second fully connected layer we got 8 neurons. Then we got 2 outputs. One is for dog, one is for cat. So the important thing for us to talk about here is that why do we have 2 outputs? We are kind of used to be having only one output in our artificial neural networks. Well, one output is for kind of when you are predicting a numerical value, when you are running a regression type of problem. But when you are doing classification, you need an output per class. Exception is when you have just 2 classes. Like we have 2 classes here, dog and cat. And we could have just done one output and made it a binary output, said 1 is for dog, 0 is for cat. So let's have a look at how all happens. Let's see from here. This information going through from very start, from a moment when the image is processed, then it is undergoing convolution, pooling, flattening, then through the ANN, then all the 4 steps. Then a prediction is made that's for instance 80% that is dog, but it turns out to be a cat, and then an error is calculated, what we used to call a cross function in artificial neural network, and we use the mean square error there, or in a CNN it is called loss function. We use a cross entropy function for that. And we'll talk about this cross entropy and mean square error in the separate video, and we'll see that how it all happens. But for now, let's say that we have a loss type of function which tell us how well our network is performing, and we're trying to optimize it or minimize that function to optimize our network. So the error is calculated, that then it is back propagated through a network, just like we had in the ANN. It's back propagated, some things are adjusted in the network to help optimize the performance, and the things that are adjusted are as usual. The weights in the ANN parts, so the blue lines that you see, the synapse, and other thing that is adjusted is feature detector, and this keeps going on, and that's how our network is optimized. That's how our network trains on the data. So the important thing is that the data that goes through the whole network from very start to very end, then the error is compared and the error is calculated, then it is back propagated. So it is a kind of a like iterated process, right? We just want the fine tuning of a network. That's all we are looking into. So let's now have a look at let's look at the really interesting part, that how do these 2 classes work, how do these 2 output neuron works, because before we have always kind of had one output neuron. What happens when we have 2, and how the situation of this classification of images plays out? Let's start with the top neuron first. We are gonna start with a dog here. So how do we, the main purpose, what we need to do first is that we need to understand what weights to assign to all of these synapses that connect to the dog, and that so that we all know which of the previous neurons that are actually important for the dog. Let's see how it is done. Let's say hypothetically we got these numbers in our previous fully connected layer. These numbers can be absolutely anything. They don't have to be that. They can be any numbers, but just for this argument's sake, we are going to agree that we are looking at specifically at the numbers between 0 and 1, and 1 means the neuron was very confident and it found a certain feature, and 0 is going to be mean that neuron didn't find a feature is looking for. So like in this case, you can see this yellow color line, meaning is the 3 neurons are firing up. Let's suppose these 3 neurons correspond to eyebrow, nose, and floppy ears, right? So these 3 neurons are firing up the eyebrow, and let's say the nose is saying nose is saying that I can see a big nose and I can see a floppy ears. So, and it's saying that to a dog and to the cat. And then what happened is that, as we know that this is a dog, by looking at these features, like maybe the features is eyebrow, this is floppy ears and the big nose, we can say it's a dog. So dog neuron knows that the answer is it is actually a dog, because at the end we are comparing the to the picture or to the label on the picture, and it knows a dog. Basically dog neurons say that so should I trigger should I be triggered in this case, because so these are my neurons, and throughout these lots and lots of iteration, if this happens many times, the dog will learn that these neurons do indeed fire up. And so when the features belong to the dog, on the other hand the cat neuron will know that it's not a cat, and it will know that the feature is firing up, and this neuron is telling me it can see floppy ears, floppy ears, floppy ears, but at the same time it's not a cat. But so basically to me that the signal that I should ignore this neuron, the more that happens, the more the cat neuron is gonna ignore this neuron about floppy ears. And so basically that's how the through lots and lots of iteration it happen often. So this is just a one example. So if this happens, maybe the 0.8 or 0.89 maybe sometime it won't fire, but overall on an average this neuron is lighting up very often when indeed it's a dog, these three, right? The dog neuron will start contributing higher importance to this neurons. And then so let's move to the next one. Now we are going to look at the cat neuron, this one. So these are going but these we are going to remember that these weights we have sorted out for the dogs. So dog is kind of pretty much ignoring all these neurons 1 2 3 4 5, means it is ignoring that, which is in this case these three was participating. Now in this case these three are participating, this 0.9, 0.9 and 1. So these are actually contributing to the cat, right? So the dog is kind of pretty much ignoring all these neurons 1 2 3 4 5, is really paying attention to what these three neurons are saying. So so now what is cat listening to? Basically the cat is listening to these three which I have told you, that this one, this green ones, and ignoring the other five. And that is how these final neurons, which neurons in the finally fully connected layer to listen to. Basically that's how the features are propagated through the network and conveyed to the output. So this is a next step, like we have already trained up our network. Like in the previous two steps we already know that which one is for cat, which one is for dog. So we have already trained up our network, and well this happens. Let's see what happens when this network is applied. Let's say we pass on an image of a dog and the values are propagated. If they are network, we got certain values. So this time the dog and cat neuron doesn't know, they don't know the image of dog here, they don't know that is dog or cat, they have no idea of what it is, but they have learned to listen to what it's been shown here. They have learned to listen to the dog neurons, listen to the three neurons, the cat neurons to these three, means the dog will listen to these three and the cat will listen to these three. So dog neuron looks at 1 2 3 and say that these are pretty high, so my probability is going to be very high, so it is a dog, it's a dog. So that cat neuron looks at these three and say, so this is one is very pretty high, but this one is very pretty low. You can see this one 1 1 and this is 0.8, it's turned to be out to be 95% probability, but the cat says like 0.1, 0.8 and 0.2. So this probability is going to be very low. Let's suppose it is 0.05. So this is how it all happens. I hope from this short little video you must have understood what is happening in the case of fully connected layer. Like in this case, if we again pass this cat image, this is how it turned out to be. Like in this case, the dog probability will be 0.21, means 21%, and cat probability will be 0.79%, because in this case you can see 0.4, 1 and 1 is contributing. On the other hand, only 1.1, 0.1, 0.8 is 1 and 0.2 is contributing. So the dog probability will be comparatively very less as we compare to the cat one. So I hope you must have understood from this short little video what is the significance of fully connected layer. Thanks for watching guys. See you next video.